How's it going? Over here for now. Could be doing a little stream on electronic stuff, or at least making an attempt. So I've got quite the mix of things here. Picked up this kit of electronic stuff, and I've been doing some Lego building, technically Duplo building with my nephew. And we built a large structure. Actually, I could probably show a little picture of it. For example, let's see. We built an elevator, and his question to me was, can we automate it? Can we make it move by itself? So I've been working on that, and it's been a process, but I feel like I might be close. Just looking for a picture of it, of the elevator. We took it apart, but it wouldn't be too difficult to put it back together. So in this stream, I'm just going to take a look at the stuff that I got and show some of the build, and hopefully do some testing here just to make sure that it works well enough to actually work in process, in reality. But we'll see. So, yeah, switch to here. We go like that. So this thing here is the original elevator, at least a little bit. That's my nephew. But the original elevator has twine, which I have some here, for the shaft. I mean, not the shaft, but the cart, whatever you call it. The elevator piece that goes, where you put people and stuff. That has 4 strings, and it keeps it stable. So we were going through the process, and I originally had just 2, and it doesn't stay very stable with 2 ropes. So 4 ropes, much better. And this is just a fraction of it. It was multiple levels. I mean, not fraction, but it was taller than what you can see here. I just don't want to show his face or anything in my photos. But anyways, that's the general idea, is that at the top we'd have some sort of mechanized, motorized, maybe not, I don't know what mechanized, but motorized thing to hopefully make it work. So that is the goal. And to make that goal a reality, I picked up some stuff from Amazon. I got a 3-pack of these stepper motors. And I have one in here, which I'm going to clean up and check and everything. I had to somehow attach Duplo to this motor, which was a challenge. That was the most difficult thing so far. But so I got the motors, and I got this pack of BOJACK electronic fun kit. So it's got a power supply, which is the main thing, because that's going to power the motor. And then I have an original Raspberry Pi computer. It's just a little computer, and it has these GPIO pins, which is the thing that's going to talk to the motor. But actually powering the motor, I'm going to use this thing that came with a kit. There's no instructions. That's going to be the difficult part. I don't really remember too much about electronics. When I was younger, I did do some kind of electronic stuff, but it's been a long time. So we'll see. We'll see how it goes with that. Anyways, I built quite the contraption for testing. And I think first off, I'm going to clean this up and just make sure it's good. But basically, yeah, I've got at least on Amazon, I'm doing multi-streaming. So on Amazon, I've got this thing linked, this kit. I've also got the pack of motors with their driver boards linked. There's a few boards and stuff in here as well, but I have one of the boards connected to one of the motors here. So there's this little motor driver board. It's got the pins that will connect to the GPIO pins on the Raspberry Pi, which I don't know if I should have it running when I connect them. And then this has 2 pins for power. Yeah. I don't know what I would do with... it's been so long. There's some sort of jumper here for some reason, but there's no instructions. So I'm going to use Google Gemini to help me, which I've been using. That's the thing that suggested the specific board and motor. Also kind of the kit, but just generically, just the kit. The specific motor is a 3-pack of 4-phase 28BYJ48. I guess I could show this. It's just a text file. 28BYJ48 DC. I would assume, no, I don't know, but 5-volt stepper motors, and then it has ULN2003 driver boards. So the goal there is you connect the board to the Raspberry Pi, and then you connect power as well separately. Yeah. So there's that. This is just copied from the product listing. I'm not super familiar with all of this stuff at the moment, so we'll see how it goes. There's some specifications. I'm going to pull this down. There's the driver board size. Here's the electronics fun kit information on their product page. But kind of the difficulty here will be actually figuring out how to wire everything up. But before I get into that type of thing, I'm going to try to clean this up and make sure it's all good to go. I can describe how I put it together. These are Duplo bricks. They're bigger than Lego. They come from Lego, but they're originally intended to be for very young kids, which my nephew's pretty young, but I think these are nice just for the sense of the size of things you can build with these compared to regular Lego. So I don't understand why they're very fixated on making these just for kids. I would feel like older people, it would be good for them as well, and anyone that just wants to have larger bricks, right? So to me, it doesn't make sense why they're marketed just to kids, like very, very young kids. But anyways, these are Duplo. Apparently, you can connect regular Lego in some way to these, certain pieces. So if you want to do that. And I also read that, and one of my family members mentioned when they tried it, when you go to big Lego events and stuff, they use Duplo on the inside and such to just fill it out more so than regular Lego, apparently. Anyways, so make sure my camera's focused properly. Hopefully that's good. So this thing as I take it apart, this is supposed to rotate. You can see it moves, but I should not be moving it because I need to remove some stuff from the motor. Because I had to very much DIY that thing. Okay. So there's that. You can take this off. I'm going to take this tape off. This is gaffer tape, so it's no residue tape. Usually no residue. Then I have some, I don't even know what this is called. It's meant for weather stripping type stuff, but it stays malleable. Yeah, I'm not sure what it's called. It's kind of a gray. It comes in rolls, thin rolls. But you'll see why I did that in a second here. Not sure what I've got on screen. Let me zoom in. Okay, that's a little better. So I'm going to get some tools here to... It's probably good. So with this stuff, just need, I put some like right by the shaft so that the glue wouldn't seep into the motor shaft. Hopefully it worked. I should not have been spinning it. So I gotta kind of remove this weather stripping stuff. I can't see up close with my glasses anymore. It's just kind of difficult. There we go. Okay. It's coming apart a little bit, like in little pieces, which is not what I was hoping for, but hopefully it'll be okay. The goal here with this stuff was to seal up any little holes. So when I used the glue, yeah, I wonder if it reacted with the glue at all. It seems similar. It's just a little bit more. Maybe it's warm in here or something. I'm just concerned that some of it might get into the motor. Yeah. The AI suggested something called BlueTack, which I don't have, so this was the next best thing, it seemed like. And it's coming out. I mean, maybe I could get some tape in there, try to get the little pieces. Yeah, the real difficulty for me was trying to attach something to the motor shaft. It's not super big, and it doesn't have any type of hole or anything. I kind of wish the motor had some sort of hole in it. I tried to drill a hole through the shaft, and I got a little notch in there, but it's so it's the material they use for the shaft is very dense metal. Uh, it seems to be working. It's just that there's some of that remaining weather sealant stuff. Yeah. Oh well. It's probably not going to be a big deal. We'll see. But before I do that, I'll try to put some tape in there. It says Pro Gaff gaffer tape. Well, okay, I don't think that's going to work too well. Hmm. Just trying to shove it in there a little bit. Hopefully the tape kind of adheres to the weather sealing stuff. It looks like it might be pulling some of it. Oh, there is still some in there. Oops, what did I do with that piece? I lost it. Huh. Well, I know it's here somewhere, but I don't see it. Oh. That's probably fine. Let's get rid of this. Yeah, a little bit more. There we go. Whoops. So it is working. You can definitely see some of the sealant stuff on the tape. Okay. So what I did here, this is a big mix of stuff. We've got a Duplo piece, clearly. The circular type. And then I used to, what type of saw is that called? I can't remember the name of the saw type, but it's got a blade and you cut things off. So I cut off the top pieces of the Duplo brick on this one right here, so it's flat. And then I drilled a hole into it for the motor shaft. And then on the inside, I was trying to think of ways to keep it fixed, right? Considering this is one of the motors. See how short this is? It is got flat sides, which is nice. Whoops. But it's very short and there's no hole in it. I really wish there was a hole in this motor shaft, like right in the middle. That would make it so much easier. But it's a very dense metal, whatever this is. The AI knew that it would not work out well when I tried to drill through it. But I did drill like a notch into it, not super deep. So there's that. And I drilled through the Duplo piece in various areas. So I've got this bigger screw, and that one pushes into the notch on the shaft for the motor. And then this thinner screw goes through and it pushes the other side of the motor piece. And it's the two flat sides. So one of them's pushing into the notch hole, the other one's in the back. So it's kind of compressing the two together. And that basically worked as far as I can tell. But then I put super glue in there, and it's been there since the morning. So it's probably relatively dry at this point. But the gel type, I've used a little bit of the liquid type super glue, and I also used the gel type super glue. So hopefully that's good enough, right? I don't think it's going to need too much, but you can see that it turns on it. My main concern is that if this isn't straight, it looks relatively straight, but you know, ideally you'd want to make sure this is perfectly perpendicular, parallel. I don't know. Anyways, I did that. That was the most difficult part. And then this specific motor has two holes, right? So you can see these two holes on this one. I just have long screws with bolts on the back, and then I have washers in there. So I drilled two holes, technically four holes, into this other piece, and I put the washers and the bolts, bolts into there and tightened it. This thing here is from GoPro accessories. It's just a sticky type of thing that you use to attach certain types of GoPro things together. So I'm probably going to use another one of those on this. but I might not need to. Anyways, that's that. This was obviously the most difficult part. So hopefully it works. Because if it doesn't work, well, yeah. I was trying to figure out, Duplo doesn't have a 90-degree adjustment, so putting it on this block didn't like do a lot for me because it's just not going to be the right direction. So I built this little structure for now. I could put some type of adhesive or something in here, but for the moment, I can just attach it in here. It slots in, locks into this bigger shaft. So you can see that's not moving. But yeah, I could put some adhesive or something. Got some behind me somewhere. That's about it. This one? I think it's in this one. So these are for action cameras. So this is basically what that was. It's a flexible dual, like double-sided adhesive, but it's not permanent as far as I can tell. Which, yeah, it's not super sticky. So I can put one of these in here. I'm trying to think if I want to right now, though. Yeah. I'll stick it in there. Yeah, it's kind of old. I don't know if that's why, but it's just not super sticky, which is what I want. Anyways, it's just some sort of double-sided adhesive thing. Let's put that in there. Boom. Yeah, so that really locks it in. Just gonna compress it in there. I think we're good. All right. Get these out of the way. So that's that. You can see the structure here. We've got the shaft. This is where you would attach some sort of rope. See that it rotates. You got the stepper motor. Hopefully this is strong enough. Who knows? I didn't really try to figure that out. But in my case, you know, you'd put this on and then you tape this so it doesn't just free fly. So the tape's going to keep it on there, and then it's going to wrap around itself or around the shaft. So obviously, if it's not strong enough, you'd have to figure out how to put some tape on here. But that type of motion obviously is pretty good with this type of brick. So I think it'll work. And put this back together. This is pretty much just for testing at the moment anyways. So with the elevator that my nephew and I will have to rebuild, I'll need probably to take this bottom piece off just so that, you know, the rope can have a way to go. Anyways, I think this went up here. This can go here. But oh, whoops. Goes there. This goes here. There we go. Nice. Oh wait, that's not quite. There we go. That's that. So there's this contraption, and then that should hopefully rotate. That's the goal. That is the goal. So we've got a driver board. We've got this electronics kit thing. We've got a breadboard. This came in this BOJACK thingamajig. Yeah. So now we need to figure out how to do this. I don't need these. He was already talking about having multiple motors. I don't know if I want to go through the process of trying to attach more bricks to a motor. That was quite the deal. So this kit comes with a ton of stuff. Got these wires that can be used with the breadboard. These ones that are got these, what are they called? DuPont wires. These are called jumper wires. I want to be careful of the little Raspberry Pi here. Oh, it's out of frame. Well, let me put the topper on here just in case. I don't want to short something when I'm flinging stuff around. It's got a USB-A to USB-A cable. So this is for power, most likely. You'll have to obviously provide your own power source in that case. I do have some USB chargers. I don't know what. This is 3.1 amp max. So that should work if it comes to that. I also have a DC power source. So this is a 2 amp DC. Oh wait, 24. Okay, 24 watt, 12 volt, 2 amp. So I feel like this would provide a lot more power than the USB. But the problem is this kit doesn't really describe how to use this thing. So it says DC in, but it says 7 to 10 volt. So actually that power source is too much. So that's not going to work. Well, I might have other ones, but I don't know. 12 volt. So that's no longer viable. Got the 5 volt USB. So this would go into here. And I need to plug it in somewhere. This doesn't come with the kit, obviously. There's some capacitors. LED. That's probably the RGB one. And then some sort of whatever that is. Could be the photoresistor, thermistor, which is a temperature thing. There's capacitors. There's 2 ICs, integrated circuits. There's buttons, which I'm going to be using. There's header connectors. Ton of resistors. Various LEDs. Yeah. Maybe I should take a photo of this and give it to the AI. See what it says. I have to get a picture on there somehow. I'll switch to face cam. I'm going to take a photo of this power board and then give it to the thing and see what it thinks. I'm going to take 2 photos. I'm going to take a photo of the bottom of it and a photo of the top of it. Because it has pins on the bottom. I don't know if those are supposed to go into the breadboard or what. But like I said, there's no instructions that I see. At least not in here. Maybe there's online instructions or something, but I'm not sure. Let's see. Go into this. Give it some change camera. So I'm going to take a photo here. Add the prompt. I'm going to take a photo of the bottom of it. There we go. Here is the, what is this called? Power supply. I'm sure there's other ways to do this, but you know, I feel like this is the easiest way these days. Here is the power supply with the BOJACK electronics kit. I'm not sure how to mount, if possible, to the breadboard. And connect it to the driver board. Oh, maybe I should take photos of the board too, the driver board. So it's this thing. Oh, I'm showing my phone screen. Let me just do face cam. I mean, there's nothing on it, but Amazon can be particular about showing phones and stuff. And don't want to dox myself, of course. So let's add a photo of this driver board. Into prompt. And on the bottom, there's nothing, but I'll take a photo of it anyways. There we go. I gave you photos of the top and bottom of the power supply and motor driver board. There we go. Let's see what it says. Anyways, yeah. I could kind of add it to the side here. Actually, I should see it in the other screen. Once it responds. Let me refresh this and see if I can see it on the screen. All right. Yeah, that worked. Nice. Turn this off. Cool. That's pretty convenient. So it says these photos are perfect. The standard MB102 breadboard power supply module. The classic ULN2003 stepper motor driver board. So I take the power supply and mount the power supply to the breadboard. Take a look at image 2, the bottom of the black power supply. You'll see 2 pairs of pins. Yeah, so we got this. Orient the black power supply module to your breadboard. Line up those downward facing pins with the outer power rails on the breadboard. The long rows running down the sides. So these ones. So this just fits like that. Line up those downward facing pins with the outer power rails. The long rows running. Critical. Look at the top of the power supply near those pins. There's a plus and minus symbols. Oh. Okay. Very, very tiny. Okay. I think it's going to go over here. Doesn't quite. Is this locked in? Oh, this is not locked in. There we go. So this was slightly off. I would explain why when I attempted it, it didn't quite work. So I think it's going to go like this. But maybe not. Maybe it's supposed to go like that. I don't know. Let's read this thing again. So look at the top. Plus minus symbols. Make sure the plus side plugs into the red line and the negative plugs into the blue. Once aligned, press the module. I would assume it's going to go into one set here. Is this not aligned? Well, there we go. Cool. So we got that. Let me give it, should I give it a photo? Just in case. Let's see. Camera. Change view. Hit the prompt. How is that? Place. On the breadboard. So just give me a little confirmation that I placed that properly. Let's see. Whoops. Let's go into this one. So yeah, there's the power supply thing. We've got our USB I need to plug that in somehow. Whoops. I don't know if I have a better option here. So that has USB-C connection. Yeah, we have a longer cable. First off, let's see what this thing said. Okay. I don't know if that worked. Oops, what am I showing? Oh, it's still thinking. Oh, it did not like that. Oh, well. Well, we'll skip that. I'm going to assume that's correct. Next. Set up your 5 volt. It says, take a look at image 1 on the left and right edges. Below the barrel jack, the USB port, there are jumpers. Port prints 5 volt off and 3.3 volts. To drive your separate motor, you need 5 volts. Pull the yellow plastic jumpers off and push them back down so they bridge the middle pin and the pin labeled 5 volts. Okay. Off and 5 volts. Do it on both sides. Okay. Also, both rails. So I can use these for power now. It says driver board, power rails. Let's look at image 3, which is a picture of this thing. I could zoom that in more so people can see it. How's that? A little bit better? I'm not sure what to do with that. Let me see if I have a extension. There we go. So let's put that over there for now. So we got that. That's in there. Let's see. Wire the driver board. Don't forget the Raspberry Pi ground. So it says on this thing, you'll see a section labeled 5 to 12 volts and 2 bare pins. Yeah. Leave the little black jumper cap alone. Grab 2 of your female to male jumper pin wires. Is it these things? Yeah, probably. I don't think there's some in here as well. These are meant to be like on board. Whoops. Jumpers. So I think it's this one. Let's see. Wire the driver board. Plug the female end. Yeah, it's got to be these. I'm going to take 2 of these. I got a red and a black, brown. Oh. No. They're both the same. How's that supposed to work? Or do I plug them into here? Probably plug them into here. It says plug the female end onto the driver board and then the male end into the hole on the breadboards plus. So I'm going to use red for plus. There we go. And then this thing, red for plus. If it goes in there. There we go. Nope, it just came off. There we go. So we got power potentially. Potential power. Now what? It says okay. Don't forget the Raspberry Pi ground. Oh, I haven't even tried to connect that. Let me unplug this. And I'm also going to unplug it from the network. So this is the original Raspberry Pi. It's got the GPIO pins on the side here. So a lot of this stuff I'm not going to need for this specific project, but so it says got the power. Don't forget the Raspberry Pi ground for the Pi's control signals. Whoops. So we want to connect this to that. It also is going to go here with buttons and maybe a buzzer. I don't know if I'm going to deal with the buzzer at this moment, though. The buttons in here? No. think that locked. Did that lock in? Yeah. So these things have double locks for some reason. So at the very least, we're going to need 2 buttons. Yeah. Trying to think if I would want to do more than 2. Move the motor. So the Raspberry Pi connections. Two buttons. Yeah. All right, that should be good. We'll see what this thing says. It says power everything, plug in the DC power, press the white tactile button. And there's a button here. I should tape this down. Alex is going to go that crazy. Let's see what it says. Those 4 tactile buttons can be confusing at first. The secret is to the legs and opposite sides to prevent accidentally wiring the buttons itself, short-circuiting. Easy method is to straddle the deep groove running the center of your breadboard. Assume like this. Is that on screen? I know it's very tiny. I got 2 little buttons. So it didn't tell me how to wire up the Raspberry Pi. Okay, step 1, mounting. Says mounting the buttons, press the 2 buttons into the breadboard so they straddle this middle channel. Trench, they call it a trench. Now the 2 legs are on the sides. I guess it probably doesn't matter where I put them. Go here. And give a little bit of space. Nice. Okay, now it says run a wire from the left side of the button to the Raspberry Pi GPIO pin 16. So these are, I'm gonna have to use these things. Kind of wish this came with more of these. I might have to buy more of these, we'll see. So it says run a wire from the left side. I mean, what's left? assume I can put it there. These are very short. On the left side. And then put this into GPIO pin 16. What? 13. I think it's one over here, but I'm not sure. Let's see. This is the Raspberry Pi Model B Revision 2. GPIO layout image. So let's look like that. The first one here is supposed to be 1. Okay, that's pin 1. 1, 2. It goes 1, 2. Huh? I don't know about that. Let's see. This one. Pin numbering. Model B revision 2. Oh no, I think this is just whatever this project. Yeah, this is not. That's not it. Let's go into the official website. Schematics. Crap. Sorry. There's a lot of whatever I'm looking at. The schematic is quite the... I just want to be sure what pin is what. Huh. It says 13's down here. If that's... It says C13. But it's not P. So I'm not sure. Here's another website, pinout.xyz. Okay, this looks a little bit better. So, got pin 1. I'm looking for, was it 16? Make sure this is actually the board that I need to be looking at. GPIO. Well, any experts in the chat? I just want to be sure that I'm doing this right. So it says wants me to put it into GPIO 23 pin 16. GPIO 23 pin 16 is going to be over here, it looks like. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 down. 1, 2, 3, 6, 7, 8. So this one, I need to recount it. 1, 2. 6, 7. So probably maybe that one. And that says, let me recount. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. Okay. Next says run a wire from the right side of the button to the breadboard's blue negative ground. So we need to, I can use a regular one of these. Oh, this has got a little strap thing. Just gonna cut this off somehow without damaging these little. There we go. Put that in there for now. So we need to connect this to that. You can use a short one. A little orange one. This to this. So there's that. Next, button 2, counterclockwise down movement of the motor. We're going to run a wire from the left side to the GPIO 24 pin 18. I need another one of these. And I need to figure out which is the... Okay, it's the next one. I've never used these. Actually, I'm going to put them down here. Yeah, that should be a little easier. So I got some more movement of things. Interesting. Next, button 2. So that was that. 24, 18. And then we need to do another ground connection. Come on. There we go. All right. We got our ground connections. We got our little buttons. Got our connection to the Raspberry Pi. And then this thing. Wait. Does it matter? I think I can use both of these. So to put this. Well, kind of rearrange things so they fit a little nicer. All right. Next, wiring the Raspberry Pi to the driver. So use a female to male jumper and connect. Do I have? I don't think I have a thing for that. Because it would need. Would I have to go through the. Maybe that's what I have to do is go through the board. So, yeah, these are all It says male to female. Using female to male jumper wires to connect the Pi's GPIO pins to the green driver board. Yeah, these are regular pins. I don't think I have. Why does it say? I think I'll have to go through the breadboard, given what I've got, but I want to make sure. So we're going to connect GPIO pin 17, GPIO 17 pin 11 to in one. Shared ground. The Pi and the... Okay. You mentioned... Whoops. Is it female to male jumper wires? No. I don't see how that would work. Unless there's something else in there. No, I don't think so. The Raspberry Pi both have male pins. Do I need to go through breadboard because I only have male to female? What are these called? DuPont wires. All right, let's see if that. We'll see. I just want to be sure. Oh, how's it going? Sorry, I just saw your message. I've been very locked in. Breadboard. Haven't used one in decades. I'm pretty good. So the goal here is I have a nephew, and I've been, for various reasons, I've been spending a lot of time with him lately, and we've been building stuff. So let me see if I can show this. So this thing here, this is Duplo from the company Lego. They're basically bigger bricks, right? And I built in a motor, a stepping motor, recently, and I connected it to one of these circular Duplos. And the goal is, because we built an elevator out of Duplo, and we were manually rotating the shaft to pull up 4 lines of twine, so something like this. And he kept wanting me to rotate it, and I told him he should do it. So basically, the idea is, he asked me if we could make it motorized, and I said we can try. So I'm working on trying to motorize a thing in Duplo so that we can potentially make an elevator or any type of similar thing to yeah, automate it. We'll see. So that's what I'm trying to do right now. That's the goal. So I bought this kit here, BOJACK Electronics Fun Kit, which came with the breadboard and a bunch of stuff. Got some buttons here. I have a power supply that came with it. And then I bought 3 different stepper motors as a pack. They're all the same. They come with a driver. So now I'm trying to figure out how to connect everything together. So it says, you're completely right. That's a great catch. Both the Raspberry Pi and the ULN2003 driver board have male pins. Usually you would use female to female wires to connect them directly. So yeah, this kit did not come with female to female DuPont things or whatever these are called. So I have to improvise a little bit. Yeah, these are all male to male connectors. So that's something that I didn't think about when I was doing this. We're going to need to go from the breadboard. It says you're completely right. Breadboard is perfect. The horizontal rows, numbered 1 through 60. I would assume it means these middle ones. So I need to. So it wants me to use specific rows. Anyways, hopefully I'll have enough wires here. Otherwise I'll have to scrounge around, try to figure something out. I don't know if I have any of these connectors. Let's see. I don't think this has numbering. $40. Yeah. All right, so I'm just going to use some of this. Oh, I could take 4 of them. 3, 4. You have to connect all of them. All right. Take 4 of these off. Man, my eyes. Here we go. Saves that. Just have to make sure they're in the right order. So purple, blue, green, yellow. There we go. And another 4. I don't know if I needed to. Oh, said, nice. Haven't seen electrified Duplo before. Yeah, neither have I. And up to this point, they're pretty nice. I kind of prefer these in some ways compared to regular Lego. But the benefit is that you can make larger, more impressive things pretty easy. Let's see. So I need to connect to GPIO. Okay, this is kind of confusing. Let's see what it said up here. So the in one, which is purple, I need to connect to GPIO pin 11 on the Raspberry Pi, which would be well, I'm going to look at this again. GPIO 17 pin 11. 17 pin 11 is going to be on this side. I'll just take these off. So yeah, something else. Hopefully static doesn't destroy anything. The sad thing is that I don't know if there's any place locally that I can buy stuff like this anymore. It all seems like it has to be bought online these days. It's kind of irritating. Best Buy might have something, but I kind of doubt it. We used to have a electronics shop within the last 10 years, but that went away as well. It's like a local shop. So, let me look at this again. GPIO 17 pin 11 to the input 1. And that is 1, 2, 3, 4, 5, 6. And that's going to be orange. 1, 2. There we go. Next, we've got pin 12, number 2. Pin 13, number 3. And then GPIO pin 15. So that was 13, 14, 15. There we go. That is connected. And critical step. run a wire from the Raspberry Pi ground, pin 6, directly to the breadboard's blue. So we need to figure out what pin 6 is. Is it actually pin 6? Or is it 1, 2, 3, 4, 5, 6? That makes no sense. 1, 2, 2, 3. 1, 2, 3, 4, 5, 6. Okay, I might be miscounting these. I might have put them in the wrong thing. Yeah, I think I put them in the wrong spot. Because it goes alternate. 1, 2, 3, 4, 5, 6. Yeah. All right. So where were we? We've got this one, 1711. 1711, input 1, which is going to be orange. Yeah, orange. Let me just make sure that's in the right spot. 1, 2, 3, 4, 5, 6. Yeah, that one's in there. Next up, we've got GPIO pin 18. GPIO 18 pin 12. Who thought of this design? So that's 1, 2, 3, 4, 5, 6. That's 6. Whoops, network connection timed out. That's fine. GPIO 18. That so PCM CLK. That's going to be where was I? Yeah, it says 18 pin 12 and input 2. 18. 1, 2, 3, 4, 5, 6. So that's going to be red. Six. There we go. Next, GPIO 27 pin 13 for input 3. So where is that? Okay, that's right under 17. Was 17 the... Yeah. 27 pin 13 for input 3. Okay, this one's going to be brown. Now right next to the orange one. Pin 3. Green. Yeah. That is correct. Pin. There we go. Next. GPIO pin 2215. Let's see where that is. Okay, this one's right under the last one. What all this means, I have no idea. I saw that one of them was like a clock counter or something. But the other ones are just standard GPIO pins. It'll depend on the code, right? So we'll have to look at the code. So that's that. Let's see what else we got here. I have some example code. What about power and ground? So I haven't done the ground thing. Driver board. Okay, that's good. Use the same exact female to male strategy for your power and ground connections, but instead of using the numbered middle rows, plug it directly into the power rails. So we've got the driver board, female onto driver plus pin. What? I don't know what it's talking about. There's like no other connections. It has power here, so I don't see why it would need that. Driver board, female onto driver pin. Yeah, I think it just rehashed it. I'm using Gemini Pro. Female onto pin or pi ground pin. What's the pi ground pin? I don't know which one that is. Critical ground, so it says pin 6, pi ground. Let me see. 1, 2, 3, 4, 5, 6. So it goes alternate. How many down is that? It's 3 down. Says that. And then I can connect this to the blue, I think. Pin 6. Yeah. Blue rail negative. There we go. I think this is it. I think we got something. Maybe I should tape these together. My trusty gaffer tape. There we go. So this could be it. This might be it. I'm gonna have to get code onto this Raspberry Pi. Trying to think of an easy way to do that. Probably just paste it in there, but close that. Let's plug it in and see what we got. So turning the Pi on. It's going to take a little bit. Let's make sure these are kind of out of the way. Got our buttons. Power source for the driver. Plug this in. It's really tight. So the driver is plugged in. Turn that on. Oh, that power supply makes quite the buzzing noise. All right. Whoops. So we got this, we got this. Oh, I need my network cable. So that's running. So that's running. I need to connect to the Raspberry Pi. Maybe we have to get the code on there somehow. Oh, change the font size again. I'll show this in a second once I get it kind of going here. This might not be loaded up yet. So it says it could not connect to the Pi for some reason. It's still blinking. Why is it not connecting? Try it again. Let's see. Is this the right address? Yeah. Open. There we go. Just, it's slow. Yeah, my password is Pi. So it's Pi. I just made the OS and wanted simplicity. Hopefully Amazon doesn't go after me for saying the word password. Let me change the font of this thing. Can't remember where is it. Appearance? Behavior? No. That window. When window is resized, change size of font. Let me try that. Yeah, I guess that's fine. Oh, it kind of stretches it in a weird way. Okay, that's not fun. Change settings. Appearance. Outside window. I can't remember where the font changes. Here it is. Let's do bold 16. All right. That should probably be good for now. Switch to here. Let's make sure this is visible. Yeah. So we need to get code onto here, and I can't think of. Let's see. So there's nano. All right. Here we've got. Can't read. Probably better just to log in visually, but there'd probably be a process. Let me see. I figure out what to do with this now. All right. All right. Says in the home directory, press Control O, which is on the screen here, right out. It's been a long time. I mean, I've used Nano somewhat recently. Whoops, I'm doing Control O in the wrong thing. Write to file. What is it? Test. There we go. Oh, it color coded it. Oh, nice. That's cool. So we got import time. Again, this is written by Gemini Pro, not me. So we've got the motor pins, got the buttons, and it's using a pull-up resistor. Remember reading about that. And then some sort of stepping sequence, debug. And then we've got a function. I don't know Python too well. I'm more about C#, but I have been doing stuff with Python in other projects. So the definition I would assume is a function, move motor. There's a global. I would assume that's a variable. And current step equals current step plus. We got a little bit of math going. And is that modulus? I can't remember. So the length of that. Yeah. So doing some math. And then here's a for loop. with an if statement and an else. So you go through this loop here in this range, whatever this function is, and then we do you check the step to 1, I guess it looks like what it's doing, and then it's messing with GPIO versus the driver board. And then there's another thing, stop motor. It's also doing a for loop. We got some print to the console. There's a try. It looks like there's a try catch loop, maybe try. Well, true. And an if else statement, except something, and then finally stop motor. Cool. Let's see. Control X to exit. And then there's our script right here on the Raspberry Pi. So this could be it. We'll see if this thing moves when I press a button. A button. Let's see how to test. Python 3. Python 3. Test. .py. Oh. It's getting stuck. It's getting stuck somewhere. What is it getting stuck on? It works though. I don't know if this is going to have the torque. That direction works. Oh, it just, for whatever reason, having this piece on is getting stuck. Hmm. Yeah, I don't know if this is going to have the torque. So, yeah, that thing's going to be so heavy. This isn't going to work. Huh. Let me ask this thing if I can. So I'm using a 5-volt USB one, but it should have 3.1 amp. Let's see. But at the very least, it works. Okay, is it being shown on screen? Yeah. Motor only requires about 0.3 amps. However, the quirk with the driver board is their internal chips actually steal about 1 volt. It means if you feed exactly 5 volts, the motor is only about 4 volts. Can you increase the voltage? Can handle up to 12 volts. You have a standard 9 volt DC wall adapter. Fits into the barrel jack. So I have a 12 volt one. I might have a 9 volt. And this thing has a barrel jack. The motor is internally rated for 5 volts. Running 9 volts gives a massive torque boost, but it's going to run hot. For short elevator trips, totally fine. Continuously for 10 minutes, it might burn out. The real elevator trick, counterweight. Yeah, true. Try the stepping sequence 1100 and sleep to 0.005. See if that changes the strength. Interesting. It says time to sleep. Slower speeds give the magnet time to grip. Interesting. All right, so it worked. Hey, that's one part of the battle. Also, this could be gripping a little too much, maybe. Who knows? I can take this off, I guess. And I could do some sort of test here with rope. Maybe I should just tape it on there, like a loop. Like that, maybe? Um, yeah, I thought the motor did look kind of small. Let's see. It makes a difference. Whoops. Let's see if I can hold this out. Here we go. Whoops. All right. Minimize that. Well, maybe I need to tie it around the shaft. Whoops. My knotting abilities are not especially great. Maybe like this. Well, I think he will be impressed at the very least that it rotates, even if we don't have the ability. What we could do, well, I could make something like this, but, or just buy a Lego one, like a regular Lego one. I mean, okay, that's not bad. Because I can pull this and it would still. Maybe it'll work. Oh, I don't have a. See, look at that. Yeah, it might work. Just my hands are so much stronger than, you know. Let's go backwards. Huh. Cool. Well, that's it. That was the what I wanted to do to test it. So at the very least, I know it works, and I know that my apparatus actually works. So cool. Yeah. Nice. All right. I'm going to sign out. Hopefully, you enjoyed this little experimentation stream. It was fun. Uh, yeah. Looks maybe I could put that back on. I kind of see if that. Yeah. I mean, if it can pull this, maybe it'll be able to. The problem is pulling something upwards. Obviously, is more difficult than. Well, there's friction, so I don't know. I don't know. Cool. We'll see. But I can work on that with my nephew and see if it's actually capable of doing what we want. But I'm sure we could think of something that would be within the bounds of the capabilities of the thing. Yeah. Cool. All right. I'm going to sign out. Hopefully you enjoyed it. On Amazon, obviously, it's more product focused. So the products in this case is this kit. The downside I've learned is that for this specific use case, connecting the driver board to the Raspberry Pi, I did not have these type of cables where it has female ends on both sides. I'll do a close up. So it comes with these, which these are DuPont connectors or whatever they're called. I'm not super familiar with the details. So they've got the male end, the pointy end, and then they've got the female end. That's just what people tend to call them. And those are the inputs. So what I would need for this specific project is to have two this on both sides. It doesn't have that. It comes with standard jumper like wires with the pointy end on both sides here. But that's just for breadboard stuff. It also comes with similar ones. These are more for breadboard where it's component to component. It's got the angled connectors on there to make them more low profile. So it just doesn't have specifically the type of cables that I could have used, is what I'm saying. So keep that in mind. But other than that, everything works, which is great. The driver connected to this power supply that came with the kit works just fine. And then the actual motor clearly works with the driver that came with it. And then I disconnected to a original Raspberry Pi. I also wish that it just had more of these in general, but it depends on your use case. So, trying to think of what else I can talk about here before I end stream. Yeah, so that's the kit. Here's the motors. So here's one of the other motors. It comes with a 3-pack. So there you can see the tip. This is a very hard metal. No surprise. I tried to make a notch in it with a drill. Just barely made a notch for my setup, but I wish it had like a hole in it. That would be so much easier. But it doesn't have a hole. But it works well enough if you can figure it out for yourself, like what you're trying to do with it. And it's got the 2 connection points on the side here. I kind of wish it had multiple, like one's going the other direction would be nice. But again, it works well enough if you can figure it out for yourself and what you're doing. But the main thing for me would be a different shaft setup. Although at the very least, the shaft has flat edges to it. So that's nice. Yeah. And then there's driver boards in here. There's another motor. Here's one of the driver boards. So there's that. Is it what the drivers look like? See what way is up. Okay. There we go. So you connect the motor to this white connector, and then clearly I connected the Raspberry Pi to these over here, and then you need a power source. So cool. And then on the back, it's just simple. So there's that. I think that covers everything. Very fun project. It's nice getting into electronic stuff again. Hopefully, can do more of that in the future. But yeah, I'm going to sign out of the different streams here. See ya. There's that. And then also YouTube. Yeah, with the YouTube channel, I'm trying to grow it quite a bit within the next 6 months. So I have a chance of getting that channel into the YouTube Partner Program for Tier 2. So if I could get it into Tier 2, it would make that channel more viable. I'm considering merging that channel with my larger channel, or at least older and more viewed channel. But I would prefer not to. The thing is, within 6 months, it's February 2027, YouTube is changing how the YouTube Partner Program Tier 2 works. They're basically, you need, instead of 4,000 watch hours in a 365-day window, so a rolling day window, you need 8,000, or you will need 8,000, so it's doubling it. So it makes it less and less viable for a smaller channel to make it into that Tier 2, which means I would get ad revenue sharing on that channel, on this channel, which would be nice. They already run ads on my videos, and I just don't get anything from it. And yeah, so it's whether, I don't know, I'm going to make an attempt, is what I'm saying, to post more here, hopefully. Stuff like this. This is fun. But yeah, we'll see how it goes. If I don't make it, if it doesn't get to tier 2 by February 2027, then maybe I'll take some of the content from this channel and put it on my other channel that is in the tier 2, because I've been kind of neglecting my larger channel and it's been going down. No surprise, you know. It's been going down in viewership, so that means less money and everything else. Anyways, yeah. So besides that, I still need like 250 subscribers, which is free on the tech channel, this one, because you need 1,000 subscribers and currently 4,000 watch hours, but it'll be 8,000 coming up. So that's that. Anyways, I'm going to sign out for now. Hopefully I'll be posting more on the tech channel coming up. We'll see. So that